I guess early or right on time.
Yeah.
Feel
the
free.
pre-class.
Okay, here's something I could ask before we get into serious conversation, just while people are fun. Why do you go by Paige and not by Kathryn?
Oh, it's actually was meant by my mother to be a double name, like Mary Ann or Catherine Ann, Catherine Paige.
Oh, yeah.
It's very Southern.
I was
And
going
no
to
one
say,
does
how
that. It's such a
Southern of you.
mouthful. Yeah. So pretty much since first grade, everyone's just dropped the Catherine and gone with Paige.
They just want to do the most efficient one syllable moniker they could
find.
But
because I was called Kathryn Paige for my early life, I've never been fully able to break up with my first name. Like it feels like part of my name. So it just ends up confusing everyone.
I love it. Kathryn Paige.
That's really pretty. Well, okay, I know people are still coming in, but we'll go ahead and get started. Hello, everyone. I'm Chelsea Lake. I'm a member of the events team at Politics and Prose Bookstore, and I'd like to welcome you to PNP Live. Before we officially get started, a few housekeeping notes. At any point during the event, you can click on the link that I'll be dropping in the chat to purchase The Genetic Lottery, Why DNA Matters for Social Equality by Kathryn Paige Harden. You can ask a question by clicking on the Q&A, which can be found along the bottom of your screen. Not to be confused with the chat, which is also along the bottom of your screen. We welcome your comments in the chat and your questions in the Q&A. We are delighted to offer closed captioning for this event via Zoom's auto captioning service. To access captions, simply click on the live transcripts option, also along the bottom of your screen. Now, it is my pleasure to introduce this evening's speakers. Kathryn Paige Harden is professor of clinical psychology at the University of Texas at Austin, where she is director of the Developmental Behavior Genetics Lab and co-director of the Texas Twin Project. She lives in Austin. Harden will be in conversation with Angela Duckworth, founder and CEO of Character Lab, a nonprofit whose mission is to advance scientific insights that help children thrive. She is the author of Grit, The Power of Passion and Perseverance. She is also a professor of psychology at the University of Pennsylvania, and in 2013 was named a MacArthur Fellow. And before I throw it over to Paige and Angela, Politics and Prose would like to thank them both for allowing us to reschedule this event, which was originally planned for October. We're so glad you're both here in January. So without further ado, the screen is yours.
Thank you so much. You were about to have Angela Duckworth and Jason Duckworth, but I just waved my husband away. Paige, I'm so excited. You know, I'm a big fan of this book. I want to ask you, what is the main thesis, if there is a main thesis? Like, what was the message of this book? And then, of course, we're going to get into more nuance.
Yeah. I'm going to cheat a little. I'm going to say that there's two main messages. And the first is scientific. So I'm trying to describe how genes make a difference for our lives, not just our height and our weight, but our personalities, how we do in school, our risk for mental illness. And that knowledge, even the idea of studying that, can strike people as scary or as disconcerting. And so the second main message of the book is, how do we make sense of that information in a way that's consistent with our political goals, our social goals, and a belief in human equality? What does equality mean if it doesn't mean sameness? So those are the two parts of the book, taking genetics seriously and taking equality seriously.
And in the first part of the book, then that's how you structured the book, right? So yeah, around those two major questions. So in the first section, I have to say, trying to explain even to my scientist colleagues, like just the basics of behavioral genetics and how genes do influence, but not in a deterministic way, our behavior. I thought you did a masterful job. And I know you cannot recap the entire first half of the book in one answer during this evening's conversation, but if you could give something of a gist of what you were trying to communicate, and especially, things that are counter to common wisdom about how genes work. If we could just begin to address that, I think that would be very helpful.
Yeah. So behavioral genetics is, it's a science that really exists interdisciplinarity, right? It's right at the edge of both thinking about our biological selves, what do we inherit biologically from our parents, but then our psychological development, which, as you know, and you study yourself, is always a person in environmental context, and this social person that's emerging over years and over decades. And so what we're trying to do in behavioral genetics is leverage natural experiments of some sort where we can pull apart tiny differences in how families treat their children, and also how biologically related families are, in order to get at this question of do and how much do genetic differences between us matter ultimately for our life outcomes. So for many years, the only ways that we had to do this were things like twin studies or adoption studies, which have a lot of assumptions. And recently, however, we're able to measure large portions of the human genome really quickly and cheaply and non-invasively, just from a sample of spit. So we still have a massive correlation problem. There's all these genetic differences between people. We're correlating with them with differences in how people's life outcomes go. That's a complicated science, but it's also a really interesting science. How do we begin to put the pieces together of being born with this stretch of a genome caused your life to go differently in some way? I think one of the biggest conceptual shifts is when we're talking about genetic influences on psychology or social development. We're not talking about single genes. We're talking about lots of genes that are operating together, each of which have a tiny effect. And we're always talking about probabilities, not destiny. So, in many ways, modern genetics is more like studying whether or not Instagram makes you depressed. You're talking about tiny effects in social contexts that don't determine anything, but might probabilistically, shift the playing field for people. That's what we are talking about when we talk about genes for depression or educational attainment. How do tiny differences in your DNA add up probabilistically to make a difference for your likelihood of experiencing some life outcomes?
So let me double click on what it means for something to have an influence. So I think you do want to say that genes have a causal force in our lives. I got my DNA from my mom. I got my DNA from my dad, and there is causal influence. But when you say it's probabilistic, not deterministic, I think what you're saying is that, the odds are higher that you're going to get whatever, this, that, or the other thing, but not that the odds are 100% or 0%. And then if that's true, so you're affirming that, but feel free to correct me in any way. Is it simply because there are so many genes influencing any phenotype, any behavior or outcome? And then, of course, we haven't even gotten to how they interact with the environment, but just the fact that they're interacting, is that why it's why is it probabilistic?
Why is it probabilistic?
It's a deep question.
Well, so at first I just want to talk a little bit more about, I think we're really good at thinking about chancy causes or probabilistic causes when we're not thinking about genes, right? So, getting the vaccine lowers your risk of getting COVID, but it doesn't completely protect it, right? There's still some odds there. Wearing a seatbelt lowers your risk of being seriously injured in a car accident, but it doesn't guarantee anything. It's when we try to think about those chancy causes with regards to genes that I think oftentimes we have difficulty, because the genes we first learn about in school are often things like Down syndrome, right, which is a chromosomal abnormality, or Huntington's disease. So these are relationships where you have a genetic anomaly or a genetic mutation, and the condition always develops kind of no matter where you grow up, regardless of where you are in place and time. And that's the wrong model for thinking about genes when we're thinking about genes' relation to our psychology. So there's lots of genes, but they're also always happening in social context, right? So if I'm, if one thing we find is that children who are genetically predisposed to go through puberty later are slightly genetically more predisposed to go further in school, right? And you can think of a really long social chain, right? Like I went through puberty late. So I went through puberty late and boys ignored me, and I had no distractions when it came to, focusing on my math homework. And I was much more likely to take the advanced math class. That's a social chain Well, if I were in a different high school, or if there were different standards of beauty, or if the math curriculum had been set up differently, then that genetic effect would have had a different effect on my life. And so that's what we mean. The part of the probabilistic is because all of these tiny effects can be moved around and pushed around by the social environment in different ways.
That's if you could, everybody could read this book, and if we could amplify, like, because that nuance, I think we would both agree, is like completely lost in, popular understanding of nature versus nurture. And I do think it has led to, unfortunately, like the omission of genes from any kind of social policy debates, et cetera. Okay, so this is, I guess related, but I'll just, say, when somebody asks me, oh, is grit in your genes, right? And then I say some version of what Paige Harden would say, but I'm not as good at it. You just pointed out that like it's multiple genes, and that it's multiple genes in concert with environment. One thing, just to get people's heads into this, like the right ballpark, like, maybe not for grit because it's not as well studied, but for height and I, for other things that people understand have been studied in terms of this intelligence, et cetera, just how many specific genes, how many specific polymorphisms have been associated with some of these things that people care about, grit, height, intelligence.
Thousands. So when we're looking at height, we're talking about thousands of different genes. There's no, there are some rare mutations that will cause you to be much, much taller or shorter, but most of the variation between us and height is because you got hundreds or thousands of variants that made you a little bit tinier, a little bit larger. I talk about in the book the example of one NBA basketball player who's 7.5 feet tall.
You have a picture of him, right?
I do. Yeah, Sean Bradley. Yeah. And he, he's not so tall because he has a large effect mutation. He's so tall because he happened to get the taller version of literally hundreds and hundreds of genes. So if you look back at the genetics literature in the late 1990s, it's really funny in some ways because you realize how wrong scientists can be. So people say we might find as many as 10 genes involved in autism. And it's turned out to be hundreds or thousands of different mutations, all of which affect tiny things scattered all throughout your body.
Now, I know you're really a behavioral geneticist, but, the molecular genetics, I do think, like, I love the metaphor that you use that, like, like there's cookbooks, there's recipes. I'll let you actually do the explaining. But I do think actually just helping people understand how you get from your DNA to like these like what is DNA doing? And again, I know this isn't, you're not in the lab in the sort of molecular bio way, but I thought you did a masterful job of explaining it. So for those who don't have that appreciation, could you share that at whatever metaphorical level, you want?
Yeah, so DNA is a large molecule and it's sitting in all of your cells. And at its most basic level, it is a cookbook, is a set of genomic recipes for proteins, which are the building blocks of your cell, the things that do things in your cell and make things happen. And then there are instructions for the instructions, right? Telling your genes when to turn off, when to turn on, in what timing, in which tissues. And these things are responsive to environmental cues. So, at the closest level, we can look at, a segment of genes, a segment of DNA. It's translated into RNA, which we've heard a lot about today, recently with the coronavirus vaccine, which gives your cells instructions on how to make proteins, whether that be a spike protein or an enzyme or something that your cells need. How we get from there to behavior is actually one of the great, exciting scientific mysteries, right? So we know that these cells are building nervous systems. Those nervous systems are developing over time. That person that's developing is developing in interaction with the social environment and in interaction with the material environment, in terms of exposure to lead, in terms of adequacy of nutrition prenatally and afterwards. So it's most well worked out what genes are doing at that first, most proximate level of analysis. And then we can take big, messy constellations of genetic information and relate them to really long downstream outcomes, like did you graduate from college? But there's a lot of steps in that causal chain, from protein to brain, from brain to behavior to personality, from personality to behavior to some sort of social, is a black box, which can either be incredibly frustrating. I think to many of my biologist colleagues, they're like, but that's so messy. How can we even begin doing that? But also incredibly exciting to think about using it as a new tool to track that developing person, watch that unfolding development as it's happening.
Now, when we talk about the causal effect of genes, and you're like, there's a really long sequence, it's not deterministic, on a very long-term outcome, are you or are you not going to get your PhD? Like how long will you live? Can you just explain a little bit about, like, okay, so I got it. You've got these like different recipes. I have different DNA than your DNA. So my recipe will be different from your recipe for this protein. And it's a black box. It's a long causal. But like, is there any example or like, how do I get to the PhD versus not PhD question? I don't know if there's anything more that you can say than you just, explained just now.
Yeah. Well, I think, the key to thinking about cause, and not just correlation, but cause, in many of the sciences is thinking about randomness, right? So if we do a randomized experiment, that puts us on firmer footing to say that something is causing something, right? I randomized someone to a vaccine versus a placebo. I looked at how their outcomes differed. That tells me something more than just seeing what's correlated with illness, right? So we can't randomly assign people to genes, but nature randomly assigns people to genes, and that's called conceiving a child. So every time a child is conceived, there's this random combination of their parents' genes, and siblings get different random combinations. And that's interesting because it allows us to look at differences between family members, between parents and children, between siblings who share biological parents, and get closer to saying, okay, if they differ in these measured DNA variants, do they differ in their likelihood of some long-term outcomes, such as graduating from college? And if so, we are on firm footing saying, well, there's something in our genomes that's causing something eventually, all things being equal about the environment, about us going to college. Again, it's very important not to read that as it's determining it, because if the environment were different, that causal relationship might go away.
Now, I know that in the Q&A, by the way, if you have questions about these twin studies, if you have complaints about these twin study limitations, I think Paige would probably be like excited to talk about all the limitations. But I do wanted to double click on this education question, because I've read the quote. I think I've even said the quote, talent is equally distributed, opportunity is not. I have to admit that, so I want to know what you think about that expression, whether you would say or tweet such a thing. After reading the genetic lottery, I've actually changed my thing to say like talent is everywhere, not necessarily equally distributed, but it's everywhere. We have every reason to believe that it's everywhere, on every continent, in every zip code. Human potential is everywhere, opportunity is not. So this idea of being different from each other, like just the very idea that, Paige, your DNA are different from my DNA, our children have different DNA. Your son may be more talented than my daughter, partly because of their DNA. Like, it's very uncomfortable. So I wonder what you think of that expression. Talent is equally distributed. And I think this is what the book is about. So again, say anything that you want on that.
Oh, I think that's such a good comment, because I think it really gets to, well, what do we mean by talent? Talent to do what? And so often, I think particularly in the US, I think particularly among highly educated professional circles, talent has become a shorthand for talent in the types of things that are rewarded in higher education, the sorts of talents that get you into a better college, the sorts of talents that get you into graduate school. And so I think I think that talent is everywhere. I think talent to do any one thing is not uniformly distributed, but that a diversity of talent for different types of things is universal, is equally distributed. But in order to realize that, we can't fetishize just certain types of talents. So, there's an idea of how do we equalize opportunity for everyone to succeed in school as much as they want to? But then what are people's skills, talents, opportunities to contribute that are not currently being inculcated, not currently being recognized in school or in the labor market? Even if they don't have this talent, what talent can be contributed? And I think we see that conversation playing out in lots of ways, such as the pushback against the idea of, skilled versus unskilled labor. I talk about this in book. If you've ever waitressed, if you have ever worked retail, if you've ever worked construction, if you've ever been a bartender, if you've ever been a farm worker, you know that that labor is not unskilled. There's a lot of skill there. And so I don't want the idea of talent being equally distributed to kind of allow us to overlook how we've kind of fetishized some talent at the expense of other talents.
Yeah, the talents that you and I have, which have been fetishized and like are very rewarded, and based on the latest economic research, like increasingly rewarded. There's like a return on intellectual, analytic talent, or skill in the marketplace. Okay, so I want to talk about the polygenic index, and I would consider it a win if this audience of intellectually hungry people tonight could, describe to somebody else over dinner what the polygenic index is. So I would like you to give us the primer on that. And you say that the polygenic index, with respect to, for example, educational attainment, right? So that collection of genes that might be related, as we know currently in 2022, as related to how far you go in formal education, is about 10 to 15% of the variation in that outcome, like can be explained to that. And then is that big? Is it small? Does that sound like a number that should make you stop and ask questions, or are you like, whatever, it's just 10 to 15%? You then go on to say that that's pretty similar to the amount of variation that socioeconomic status of your family can explain. And so Paige, what does it mean? What is a polygenic index? Yeah. And so I can interpret this, these statistics that you mentioned.
Yeah, so poly means many. So polygenic index is a number that adds up information about many genes. So what's happening is researchers are measuring your genes. They are measuring variants that you have, and they are adding them up. And they're adding them up by multiplying each set of genetic variants you have by how strongly those genes are correlated with some outcome that's been studied in another study. So I've done let's say I've done a huge study of whether or not children have ADHD. I've calculated which genes are correlated with being more likely to be diagnosed with ADHD. And now I take that information and I apply it to your genome and I add it up into a single number. So that's my best guess, given just information from your DNA about your likelihood of having an ADHD diagnosis. There's a ton of uncertainty around that for an individual person, right? I wouldn't be able to tell you with any great degree of certainty, yes, you're going to have ADHD or your kid's going to have ADHD. But if we look in a population, when we're restricting it to people who have recent European genetic ancestry, so those are people who are most likely to be identified as white in the US, that polygenic index, that number, is as strongly correlated with someone's likelihood of graduating from college as their family income is. So that number is around 15 to 20%, depending on the sample. So 15 to 20% can strike you as small, right? Like we're used to thinking of all the ways that, say, family income can advantage someone in education, and then you think it's only 15 to 20%. But again, most of our life outcomes that we're measuring in free-range humans are really unpredictable. We're bad at predicting them with anything we measure about a person. And so relative to that kind of baseline level of unpredictability, this polygenic index, which again can't tell you something about you with certainty, but it can tell you something about in a population on average, who is more likely to graduate from college and who is less likely to graduate from college. So now there's good polygenic, and by good, I mean there's correlations strong enough that it's worth putting it in a study, right? So psychologists often think that if, as long as something's correlated like 0.1 to 0.3, it's kind of worth including in your model. So there's polygenic scores related to educational attainment, schizophrenia, body mass index. We recently did one on externalizing, which is around sexual behavior, ADHD, impulse control problems, depression. So increasingly more of our psychological differences have been related to some polygenic index or polygenic score.
And are these like all around the same power in terms of like, because oftentimes I'm asked like, what's more heritable, like grit or IQ, extroversion or being ADHD. I think when I went to graduate school, which isn't that long ago, I was taught like, they're all none of these things are like dramatically more or less heritable than anything else. What do we think in 2022?
Yeah. So actually, when we look at the genome-wide association studies, which are the studies that correlate specific bits of DNA with some measured outcome, and then with the predictive power of polygenic indices, actually educational attainment is one of the best ones. It's far more predictive than, say, something like alcohol addiction or opioid addiction, which I think can surprise people. We're really used to thinking of addiction as having a biological component, that you might inherit something from your parents that makes it more likely for you to struggle with drugs or alcohol. And yet when we're thinking about the genetics, it's actually been much easier to find specific genetic variants associated with education than with depression or addiction. So when we're looking at twins, the general rule of thumb is it's usually about half and half, right? It's about half heritable, half the environment. When we're looking for measured genes, it depends a lot on the availability of data, how good it's measured, and how heterogeneous the phenotype is, right? So if people all through get through education, because educational systems tend to reward the same things, then you're going to end up with a much clearer genetic signal than you might see for something like depression, where everyone is labeled with depression, but actually they all have something a little bit different and a different constellation of symptoms that might have a different underlying biology.
A lot of people have heard of the bell curve. Not a lot of people, I think, at least in our generation, have actually read Herrnstein and Murray's bell curve, but I know you have. So can you, revive a little bit of the bell curve controversy, and then tell us what what was the bell curve? Like, who are these people, Herrnstein and Murray? What do you think of all this? Is this like the antidote to the bell curve, or the sequel to speak on the bell curve.
So I think the thesis of the bell curve is really summarized really well by its subtitle. So it was the bell curve, intelligence and class structure in American life. And so their thesis was that one, intelligence is measured by intelligence test scores, is heritable, it's influenced by genetic differences between people. That two, those intelligence differences are the largest determinant of socioeconomic success. So if you think about income or wealth, occupational status, non-marital childbearing, all the things that people were studying in the mid-1990s as good or bad social outcomes, that they were really driven by intelligence as measured by IQ. The three that meant that social policies designed to bring about greater social equality were kind of destined to fail, that genetics was destiny. And if these things were genetic, they were immutable. We're not going to be able to fix them in any way. And fourth, and this was the most controversial part of the bell curve for good reason, is that those heritable, immutable genetic differences in IQ fell along racial lines, such that racialized differences that we saw in income, education, occupation were due to these sort of inborn characteristics. So I think one mission of my book is to try to peel off the very deceptive parts of truth that are in the bell curve, so that the falsehoods can be seen more clearly. I think that the impulse when faced with an argument like that is often to throw the baby out with the bathwater, to say that it's not just that there's not heritable racial differences in IQ, but that IQ tests are worthless, and that twin studies are worthless, and that intelligence has nothing to do with educational
And then
success.
to talk about genes in any sense is just racist.
Is just racist, right? And, which I think really actually backs people who might be very well-meaning into a kind of an untenable rhetorical place. And so I differ from them in that I think that IQ differences are heritable, but that does not mean that they're immutable. We have good examples of, changing heritable characteristics through environmental interventions that intelligence contributes to, but is by far from the only or even the major determinant of social success in America. There's no evidence for racial genetic differences. Race isn't a genetic concept. And what's more is that we don't have to look at the way that things are distributed and throw up our hands and say, I guess we need to abandon our social and political and moral commitments. I'm really interested in, if we are committed to a multiracial democracy, if we're committed to people economically participating as equals, what do we do with this information? How can we use it as an ally and not as an obstacle?
Okay, so race, which again, I agree with you, like that was the most,
incendiary.
I was thinking for like explosive, catastrophic, Chernobyl, and again, for good reason, aspect of the bell curve debate, but then we have this legacy of that. So you distinguish in this chapter on ancestry and race between race and ancestry. For clarity, I mean, not that everyone has to agree with you. How do you define the term race? What is the difference between race and ancestry? Are these biological constructs? Are they social constructs? Like distinguish these.
Yeah. So I think of ancestry as something that's saying something about a process that's very individualized. How are you connected to your ancestors, your parents, your grandparents, going back through time? When we look at that, we can see that people who were living close to one another were more likely to have sex with one another, so they have more genes in common. So we can see a geographical distribution of genes, and we kind of put labels on top of that reflect that geography and history. But those ancestral groupings are not just about genetics. We can also think about ethnic heritage. We can think about linguistic ancestry. We can think about how has religion been passed down over the course of your ancestors. So ancestry can be something that's very personal, but we can see a record of it in which genes you happen to share with other people by virtue of having common ancestors. Race is a much cruder distinction. So in the US, sometimes we've had 2 racial groups, sometimes we've had 5, but it's a very kind of lumping together of people. It's very binary. And historically, it's been invented and used to regulate kind of this hierarchical access to space, like who gets to be where, who gets to do what with their body. So it's a very static concept that's assigned to you. Because we see observable differences between races, right? Like in our hair color or in our skin color.
Like you and me.
Like we look different.
Yeah, we look different.
Because we have different genetic ancestors and we've been assigned to different racial groups. We tend to think that people who are the same racial group are more genetically similar to one another, and people who are genetically, who are in different racial groups are genetically different from one another. But the power of genetics is we actually see that's not true. So for instance, you and I are probably more genetically similar than 2 people from different tribes in Africa who would both be labeled as Black in the US. And I think that's the sort of finding that kind of can blow people's minds, that we're so used to categorizing people and then thinking of, hey, this is how people are genetically similar and this is how people are genetically different, when in fact the decline of genetic differences between people is really poorly represented by these either or social groupings of race.
I'm going to get to the questions that have been filling up the Q&A in a minute, but so if you haven't put and also I will be asking the most upvoted questions, so you can participate in that way as well. But you really go to great lengths to say that we know a lot about individual differences in outcomes as they relate to genes. But you go to great lengths to say that does not mean we know a lot about group differences, Asian, white, Black, white, or even like other group differences that, like you can name any. And can you just explain why you can't just go from these studies of twins that say, hey, there are these individual differences in their genes and they explain the outcomes, to like, why can't you make the leap between, what about this social group and that social group, or this racial group and that racial group?
Yeah. And I'm going to add one thing there, which is that we know a lot about individual differences in one group, which are white identified people in high income countries. And that's where the majority of twin research and genomic research has come from. So there's a kind of classic thought experiment about this, which is, imagine that you have this beautiful garden and you have planted a bunch of different plants in your garden, and you have made sure that your garden has the best possible soil, nitrogen, fertilizer, acidity levels, moisture levels, shade levels. It is the opposite of growing plants in Austin in August. It is perfect. And at the end of your growing season, you look and you see that some plants are taller than others. And you've given them all ideal conditions. And so you assume, well, these seeds were genetically taller than these seeds, and that makes sense. And then you look over at your neighbor's garden, and that looks like kind of my garden, maybe, perhaps some days, which is like, intermittently watered and like blasted by the sun. And, the big rocks have not been dug up. And you look over at those plants and they're stunted. It would make no sense for you to say, because the plants that were taller in my garden were the genetically taller plants, those plants over there must be short because they're genetically shorter. The environmental conditions don't allow you to make that inferential leap. And I think if we think about the history of institutional racism and oppression that particularly people of color have experienced in this country, many of our children still experience that rocky garden. They go to schools that are not good schools, and then they don't do well. And to go from those individual differences in high resource contexts to saying, okay, now I can say something about what's happening in these under-resourced contexts, it's just a logical fallacy. It would be a logical fallacy regardless of whether we're about genes or not.
That's a terrific metaphor, and I wish it weren't like so true. But yeah, anybody here who wants proof, just go to your local urban public school system and ask yourself, what chances those kids have to develop and to demonstrate their potential. Okay, so let's go to some questions. One from anonymous attendee, but upvoted a lot. I haven't had time to read your book yet, but I did read the New Yorker article about you that ran a few months ago. Did you find your New Yorker profile fair and accurate?
That's a really hard question to say.
That's a great question. I like that because I read your profile too.
I actually feel like I might be the worst possible person to ask about that, because I think you can never see yourself clearly. And I don't think you can read about yourself clearly either. So I think you would actually, Angela's a better person to ask that question of than me.
I thought it was really flattering, by the way.
I will say that you
come up as a total badass. Like, go Paige Harden.
The writer of the New Yorker article really did his homework. Angela's done this too, I'm sure, talked to a lot of science reporters in her career. And, you send science reporters, you might talk to them for an hour, and then they might come back to you with a few questions. You might send them something, and then they might say, great, thanks. I've never worked with a science reporter before that read what I sent him, looked up the references, read those, and then sent me screenshots of footnotes from the references of the references to say, but doesn't this contradict the thing you said in paragraph 5? So I think, the depth of time, a New Yorker staff writer writes 2 articles a year, which means that they spend 6 months learning about a topic. And I think that's an amazing thing in this day and age. And I cannot speak highly enough of the New Yorker's fact-checking section, who really will call you. And Angela's been on the receiving end of this too.
Good stuff. New Yorker
they dot their I's and they cross their T's for sure.
Okay, so you did not count that as fake news, and I didn't know all the things that you said. But
No, not
that
at
is
all.
impressive. For anybody who's choosing between them, I still recommend Paige's book, but it is a great New Yorker article, and I'm sure there are a lot of New Yorker readers here. Okay, I'd like to hear Paige engage with Dorothy Roberts' critique that focusing on genetic causes of social inequity fits into a eugenic past and has the unintended consequence of distracting us from more powerful structural causes of inequity.
Yeah, so I think this is a really common viewpoint, which is this kind of zero-sum game, right? That we have a limited amount of political will and attention in its genetics or its structure. And I do not think of them as an opposition. I think of genetic influences as showing us something about what our structures are, who is advantaged, who is systematically disadvantaged. They're a tool to help us figure out if we dismantle structures, what are we replacing them with? And they are another dimension of inequity that stands along the other dimensions of inequity that we're used to thinking about as egalitarians. So if I, as a feminist, say, I'm interested in how women's life chances are systematically different than men's, I don't consider that a distraction from thinking about socioeconomic inequality. And in fact, I want to know, how do these intersect? How do the lives of poor women differ from rich women? How do certain forms of failures of class consciousness hurt feminism for poor women? I think of genetics and our embodied phenotypes as another dimension that intersects with the things that we're used to thinking about in terms of structural inequality. We should not be thinking about genetics or the environment, but how are our structures advantaging certain people with certain genotypes? That's the question that I'm interested in scientifically and politically.
Yeah, I thought that if you hadn't chosen the great title that you chose, you could have chosen like not either or, it's both and.
Yeah, I probably should have. I think it might have.
No, this is good.
Plus, allayed some misapprehensions about the book if I'd been like, it's always both.
It's always both and. No, I think that's a profound, but hard to communicate point. Okay, so here's another question. As we get better at correlating genetic outcomes, healthcare will provide more newborn screening. Does that represent an egalitarian problem? And how widespread do you foresee screening, presumably like genetic screening, becoming? And actually, thank you, anonymous attendee, because I was going to ask you, I'm sure a million people have asked you about like 23andMe and, I can't remember if you've written, I read your book when it first was written. So like whether you talked about getting genotype, et cetera. But yeah, can you speak about screening and, the future?
I think that genetic prediction is going to become more ubiquitous rapidly. I recently changed my life insurance and I had to get a medical exam for my life insurance. And as I did that, I was profoundly aware that in most states, the use of genetic information and genetic life insurance actuarial judgments is not covered by law. It's not covered by federal law.
Not covered as in not allowed or not prohibited or just
not prohibited, not discussed, right? So the Genetic Information Non-Discrimination Act covers health insurance, but not life insurance or long-term disability insurance or car insurance. So, to go back to what I was saying about polygenic indices, it's not super accurate for one person, but it's predictive of a trend in the population. And for many insurance underwriting decisions or other decisions, right on average is all you really need. So I think there actually needs to be a really urgent regulatory conversation about for whom, when, and who has access to that information. A lot of times I get frustrated because I think so much of our ethical conversation focus on the work of knowledge production. So people like me, like doing the GWAS, and not enough on, well, who has access to that information?
Yeah, the application.
And what are we going to do with them? There's a law professor, Joseph Fishkin, whose work I have recently discovered and a very big fan of, and he's written a book called Bottlenecks. And he talks about things like not using credit history for employment applications. And I think we need to have a conversation in those ways, which is, how do we avoid genetic information being used to narrow bottlenecks to opportunity for people?
I just became aware of his work too, like in the last month, and super fascinating, right? To just like think about these
think
things.
about the parallels. Yeah. Educational bottlenecks and other sorts of bottlenecks.
Okay, so you're not going to give a glib answer to whether, screening is good or bad, whether I should be submitting my 23andMe, results with my next life insurance renewal, because it's complicated, it sounds like, but you are saying unequivocally we should have a conversation.
I think every technology, we're always thinking about how do we mitigate risks and how do we maximize benefits, and good or bad for whom, under what circumstances,
and with what trade-offs, because there's always going to be trade-offs. Okay, so does knowing your polygenic score represent a greater risk of a self-fulfilling prophecy or external perception, like than even standardized testing? Like say I get a polygenic score that says, Angela, you are very unlikely to go very far in your education, or like you have a very high likelihood of being morbidly obese. I think that's maybe the spirit of the question. Like, does that lead to the self-fulfilling prophecy of like, well, I guess I'll finish this Haagen-Dazs or whatever. And, maybe even more so, I guess, is the implication than standardized testing, if you think that has that effect also.
Yeah. I think the answer is still really out on that right now. I think there needs to be a lot of meta science about how that science is interpreted, received, how it influences future behavior, how different framings of it, do they matter, in terms of how people understand that information. What we know is that not getting a polygenic score, but just given genetic explanations. So people who struggle with being overweight are more likely to have a heritable predisposition, really can be a double-edged sword. So it can reduce blaming. People are less likely to morally blame themselves, but also can increase feelings of helplessness and lack of control. How that works in an educational context, particularly remember, kids are constantly receiving feedback about how they're doing in school, good or bad, informal and formal. So in that context, which is already very self-information rich, what kind of interpretations would particularly a young person have around their own genotype, I think is really, really unclear, but a really interesting area of research.
And the research that you were just referring to is, I guess, and I think I know these studies because your advisor and maybe you were on them, right? But I think you're saying that, like, say you say to someone, did you know that obesity is influenced by your genes?
Yeah.
And that tends to not inspire them to try to eat a healthy diet, because they're like, oh, well, and there is a kind of like, well, there's nothing I can do.
Yeah. But they're also less likely to say, because I'm overweight, I'm a bad person, or I'm a person that lacks willpower, right? So I think what we want is, how do people have compassion for themselves, but also efficacy moving forward, and agency? And what is the best way to accurately convey scientific information that promotes that type of, compassionate efficacy? I think that's a lot of therapy, actually, to think about it. Like, if you think about it, like a theme of a lot of like CBT is, it's not your fault, but it's your responsibility. And so, moving that into the genetics education sphere.
I like shout outs to therapy, because I feel like we should shout out therapy whenever we can. Commercial therapy is great. I agree with you. Okay. Here's another question. When it comes to policy implications and making the point that the US is not a meritocracy, what does understanding genetic differences within a specific population provide us above and beyond understanding systemic or systematic disadvantages that we know are still very prevalent in the US? Or how can understanding both these things contribute to arguments in favor of social inequality? And actually, one of the questions that I did write down, and so, to this question, I just wanted to append mine, was like, what is anti-eugenic policy? And I think these are at least related.
Yeah.
And can you give a specific example?
Yeah. So I think with meritocracy, what does genetics add to the criticism of meritocracy, or America as a meritocracy? I think there's two levels. The first is as a scientific tool that makes the critiques of meritocracy empirically stronger, right? So often now we have people, and I'm one of them, that says, look at the uneven playing field, like look at the ways in which family wealth structures people's opportunities. And often that research has a weak link, which is that we're correlating aspects of parental socioeconomic status with how kids are doing. And someone who's really invested in the meritocracy narrative can say, it's not the poverty, it's just that the richer parents happen to have genes that they're passing on to their kids, and that's what's happening here. And it's, as much as it might hurt sometimes for some people to, steel man that critique, instead of waving it away, I think addressing it and saying, look, even when we control for genetic differences between people, we still see the systematic advantage of family economic opportunity on education, as I think rhetorically the best way to deal with that. But even deeper than that, even beyond giving us a tool that shows even more starkly how America is not a meritocracy, I really want people to question whether they want America to be a meritocracy, whether ever it could be, right? Because, and I think this is maybe the more controversial or provocative part of my book, but why does it bother us that kids born into a rich family have different life chances? It's because they had this morally arbitrary stroke of luck at birth that advantaged them their whole life. And why does that mean that they get more of everything? Aren't our genes also that morally arbitrary stroke of luck? As a luck egalitarian, I'm interested in what do we owe each other in terms of our equality of goods, in terms of our equality of ability to participate and have a thriving life, regardless of either accident of birth. And I think that means actually kind of getting over the idea of meritocracy as the highest good. Meritocracy can be instrumentally useful because we want skilled people in certain professions, but as an end-all be-all of justifying inequality, vast amounts of inequality in this country, I don't think it goes nearly, I think it's really deficient in a lot of ways. And I think it's interesting that as a scientist, I've come at this critique of meritocracy at a time where so many other people have too. Michael Sandel, for instance, is a political philosopher, and he was writing his book right before mine. There have been so many people kind of critiquing this idea of meritocracy.
So if you had to choose between distributive justice, like based on the outcomes, versus procedural justice, like, hey, there's the same number of hurdles, let's see who gets to the end, and however the outcomes get, do you then lean toward distributive justice versus procedural justice?
Yeah. In some ways, as it's true from the book, I was very much influenced by Rawls, which is in some ways, it's like, what procedures would you set up if you were trying to think about, you would have no idea where you would be, you're behind that veil of ignorance. And so there's this kind of sense of, well, I want procedures that are fair. We all know the rules, but that will result in not gross inequities depending on my starting point in life.
Okay, Robert asks, thank you so much first for rescheduling this event, Paige. Given what neurologists have been learning in recent years about the brain's plasticity, isn't it becoming increasingly apparent that environment shapes an individual's cognitive development far more than genetics? I recently listened to a live stream event in which a Yale neurologist said that people who grow up in literate societies, literally, have different brains than people who grow up in illiterate societies. So what do you have to say to Robert?
Yeah, I just really twang at this more than. I use this example of, genomes are sort of like cookbooks and lives are like, you going out to a birthday party with your friends at a restaurant. And if someone asked you, what was more important for your meal today, having salt in your food or having a chair to sit in, you would be like, that question makes no sense. I need both of those things. When we're thinking about normally developing genotypes and the extremes of environmental experience, environment seems like it matters more when we're looking at how two children raised in the same family can end up so different, then genes seem to matter more. And that's two sides of the face-face illusion. They're all in the life of a person, they're always working in concert. And it doesn't really make sense to think about one being more than the other.
I'm going to ask a question since we're getting close to the end of time. You've done research on the heritability of character, including, grit. And when people hear that height is heritable, they sort of get it. And even I think when they hear that intelligence is heritable or risk of skin cancer, they sort of get it. I think it seems less intuitive to people that character, motivation, how long you stay at, at basketball practice, your grit are heritable. So I guess I have a question, which is two parts. Like, I think you mentioned this, but I just want to ask it directly. Are there meaningful differences in just how heritable these things are, or are they all close to 50-50 in terms of heritability versus environment? And if that's, like, well, they're about the same heritable, but why would that surprise people that some things, why does it go counter to intuition?
Yeah.
That's a question I've long wanted to ask you. So go ahead.
Yeah. So there are some differences. Like if you're looking at very basic cognitive abilities, like, redirecting attention, we're looking at much higher heritabilities on average in childhood than we are for personality traits, which I would consider, much of grit or conscientiousness or self-control is more in that kind of motivational personality space, which was like more 30 to 40%. I would encourage people to think about, if it's a hard time making sense of that, to think about their own families, think about your own kids, think about the classrooms that you've seen, think about you and your siblings. There are skills and habits that can be entrained and practiced and learned. And there are individual differences between people in how painful they find that and how easily those skills come to them and how much practice it takes to acquire them. I see this in my own family in terms of like which of my children needs a brain break every 5 minutes to run around the room and which child will go sit in a room and read for 4 hours without moving, right? I think it's often hard for us because of the way that we have moralized success in education. It's the two ways that we use merit or skill, both in terms of a functioning that someone can have and more easily acquire, but also almost like it's a virtue. And I think it's the virtuizing or the moralizing of educational skills that then creeps us out with good reason when we realize how much of these skills are attached to our biology.
Yeah, maybe it's I thought it was under our control and moral and our duty. And then the idea that there could be any genetic influence on that seems antithetical. And maybe, again, back to the both and, right? Because there's this either or assumption that underlies it. So Paige, I think we're just about out of time. I wanted to ask you if there are any parting words of advice. We started with like, what's the gist of the genetic lottery? And then you're like, I'm going to cheat. I'm going to say these two parts. But in this hour, we've covered a lot of territory. Is there anything that we haven't covered that you want to leave us with?
Whenever I go into these conversations, I always have this moment beforehand where I'm like, but what are we going to talk about that I haven't already said? And then I start talking about it and I realize I love this topic because it's about humans, right? And we lead these lives in which we are trying to exert agency and control and get better at things and do things that we feel proud of. And we also live our lives tethered to our biology and to our constraints and to the fact that we are, mammals that are embodied. And so I guess I would encourage, if you haven't read the book, I would love for you to read it and be curious about it, and be curious about just kind of the awe and curiosity that you can bring into thinking about what it is to lead these human lives that are psychological and biological at the same time.
I truly love this. If you read it, you do or do not have, you can do whatever you want with Post-its, but my copy is heavily underlined. And John Rawls was unable to blurb your book, Paige, but I think John Rawls would loved it. So I want to thank you, and I want to thank Politics and Prose for allowing us to have this amazing conversation. Also want to thank everybody who contributed questions, and apologize to those whose questions I didn't get to this evening.
Thank you so much.
Yes, thank you both so much. What a pleasure it's been listening to this hour-long conversation. I think I speak for everybody when I say, I wish we had more time. But to get more information, please, as a gentle reminder, I've posted the link to purchase the genetic lottery in the chat. It'll take you directly to the Politics and Prose website, where after you purchased your copy, I hope that you'll visit our events page. We'd love to see you at another event soon. In the meantime, thank you both so much. Stay well and stay well read.
Good night.
Thank you.
Bye-bye.
To be
Good night.
continued.